Throughout this series, we've explored the main development phases of ISO 26262: concept development, system development, hardware development, software development, and activities after production. But throughout all of these phases, a number of supporting activities are required. These activities are collected in ISO 26262, Part 8. Supporting processes. Rather than defining new development phases, Part 8 provides the supporting framework that helps ensure consistency, traceability, and confidence throughout the entire safety lifecycle. In this video, we'll explore the major topics covered in Part 8 and understand how they support functional safety across every development phase. Before looking at the individual clauses, let's first understand why supporting processes are so important. Supporting processes are different from development processes. They do not define the system architecture. They do not implement software, and they do not create hardware. Instead, they support all of these activities. Supporting processes help organizations manage information, control changes, verify work products, and ensure that development remains consistent across the entire life cycle. Without these activities, maintaining functional safety would become increasingly difficult. Now let's look at the structure of Part 8. Part 8 covers a broad range of supporting activities. Rather than following a strict engineering workflow, the clauses address different topics that support development across the life cycle. These include managing interfaces, handling safety requirements, configuration and change management, verification, documentation, software tools, reusable software components, hardware evaluation, and several specialized topics including proven in use and safety elements out of context. Let's begin with the first group of supporting activities. The first supporting activities focus on managing information throughout development. Interfaces between teams and organizations must be clearly defined. Safety requirements must be specified, maintained, and communicated consistently. Configuration management ensures that the correct versions of work products remain under control. Together, these activities provide stability and traceability across complex engineering projects. As development progresses, however, another challenge appears: managing change. Development projects constantly evolve, requirements change, designs improve, problems are corrected. Part 8, therefore, includes structured change management activities. Every significant change should be evaluated before implementation. Verification activities then provide confidence that work products continue to satisfy their intended objectives. Together, change management and verification help maintain product quality throughout development. Supporting development also requires accurate project information. Documentation is another important supporting activity. Engineering decisions, requirements, verification results, and many other work products must be properly documented. Part 8 also addresses confidence in software tools. Modern development relies heavily on engineering tools, requirements management systems, compilers, static analysis tools, and many others. The standard provides guidance for establishing confidence that these tools support safe development. Another important topic concerns the reuse of existing software components. Not every project starts completely from scratch. Existing software components are often reused across multiple projects. Part 8 provides guidance for evaluating and integrating these components within safety-related systems. It also addresses the evaluation of hardware elements that may already exist before the current development project begins. These supporting activities help organizations reuse proven solutions while maintaining confidence in functional safety. The final clauses address two specialized but very important concepts. The final clauses of Part 8 introduce two concepts that are frequently encountered in modern automotive development. The first is proven in use. This concept allows organizations to consider operational experience as supporting evidence under certain conditions. The second is the safety element out of context, often abbreviated as SEOOC. This enables the development of reusable safety-related components that can later be integrated into different systems. Both topics are extensive enough to deserve dedicated videos, so we'll explore them in much greater detail later in this series. Before we conclude, let's see how Part 8 fits into the overall ISO 26262 lifecycle. Unlike the previous parts of ISO 26262, Part 8 does not focus on a single development phase. Instead, it supports the complete functional safety lifecycle. Whether engineers are defining requirements, developing hardware, implementing software, or preparing for production, supporting processes help maintain consistency across all activities. This broad scope makes Part 8 one of the most widely applicable parts of the standard. Now let's summarize the key points. ISO 26262. Part 8 provides the supporting processes that enable successful functional safety development. These activities help organizations manage information, control changes, verify engineering work, establish confidence in software tools, reuse existing components, and support functional safety throughout the complete lifecycle. Although these activities often operate in the background, they are essential for achieving consistent and reliable development processes. In many ways, Part 8 is the glue that connects all of the other parts of ISO 26262. If you want to go beyond this introduction to ISO 26262, we offer comprehensive online training programs on our website. These self-paced courses cover functional safety concepts, ISO 26262 requirements, practical implementation approaches, and real-world engineering applications. The focus is not only on understanding the standard, the focus is on applying it effectively in automotive development projects. You can find the link in the video description and also in the pinned comment below. If you found this video helpful, please consider giving it a like and subscribing to the channel. We regularly publish content on functional safety, ISO 26262, ASPICE, ISO 21434, and other engineering standards. Thank you for watching, and we look forward to seeing you in the next video.